Okay, hi everyone. I want to do three quick calculator problems for you to show you something pretty cool, which is that we can use our calculator to get a definite integral, right? So let's look at this first problem on this worksheet. I'm going to do the first three, and then hopefully that gives you enough to do the next seven with your calculator. So the first one says if f prime of x is equal to that square root of x cubed plus 6x, and f of 1 is equal to 2, what is the value of f of 5, right? So here we're going to use our net change theorem. And the net change theorem, of course, says that the you got to think of the f of 1 equals 2. You want to think of this as your a, and you're being asked for f of 5, right? So this is going to be our b. And the net change theorem tells us that f of b is going to be equal to f of a plus the integral from a to b of f prime. Okay, so that in this case, f of 5, which is what we want, is equal to f of 1, which is 2, plus the integral from 1 to 5 of this function, which is the f prime function, x cubed, square root of x cubed plus 6x dx, right? So once you write that equation, all of this should really be on one line. It's like that, right? That's the equation. Once you figure that out, you can go in your calculator, and here's a function that we don't really know how to find the antiderivative of this, right? If we did, we could find it without a calculator, but we don't, and so we can use something called the Math 8 key on your calculator to do a definite integral. I kept this a secret until now, but now I can tell you. What we do is turn on your calculator and go to the math menu right here. Same one that you use for the derivative, right? So math. And then we're going to scoot down to math. Oh, sorry, math 9. Math 8 is the derivative, so we're going to do math 9. So we go enter, and you get a nice little integral box there, right? And so you can just put in the numbers. So we're going to put 1 on the bottom and 5 on the top. And then in here, I'm going to put in the square root. So second x squared gives me the square root. And then always using this for our x variable. Every time you use a variable x, we want that. So we go x hat 3, and then arrow down, and then do plus 6x. And make sure you put dx here. That's the variable of integration. Hit enter, and ta-da, we have a number 27.9783. We want to keep that to 4 decimal places. So this will become, this answer becomes 2 plus 27.9783. Final answer 29.9783. Okay, so that's our first problem. Okay, let's take a look at the next problem, which is a velocity, acceleration, position problem, right? And we want to remember that we have our ladder, so we've got position, and then velocity, and then acceleration. So these are like, you can think of this as your f, and then f prime and f double prime. The point is that the velocity is the antiderivative of the acceleration. The position is the antiderivative of the velocity, right? So our net change theorem can apply in this kind of problem as well. So question says that a particle moves along a horizontal line so that its acceleration at time t for t greater than or equal to 0 is given by a of t, that's the acceleration function, and that is equal to t times the square root of t to the 4th plus t, okay? And t is measured in seconds, position in feet. If the velocity at time 2 is equal to 5 feet per second, what is the velocity at time 4, right? So we've been given v of 2, and we want v of 4. So once again, this is our a, this is our b, And the net change theorem would say that v of 4, f of b, is equal to f of a, b of 2, plus the integral from a to b of f prime, right? Which is really just v prime, but v prime, remember, you go down to, you take a derivative, you go down. So v prime is just a. So v of 4 is going to be equal to 5 plus the integral from 2 to 4 of a of t, which is this guy up here, right? So we just have to put that in here and solve with our calculator. So you take out your calculator, and it's so easy now that we know. Oh, let me clear some of this out. Oh, what did I do there? Okay, we are just going to do that integral in here. So we have to do, we can do the 5 plus and then math 9 and integrating from 2 to 4 and then put in the function here, always using this guy for all the variables, no matter what they're called on paper. They are going to be called x in the calculator. So x times x to the 4th plus x, okay, and then dx, the variable of integration, hit enter, and ta-da, we have an answer, 65.9886. And that's the correct answer for the velocity at time 4. Always want to keep everything to 4 decimal places, and that is in feet per second. Okay, and we're on now to our last problem that I'm going to show you, and then you have 7 more, which hopefully shouldn't be too bad, because you can use your calculator for everything, and the amazing Math 9 button. Anyway, here we have the function h of x, which is equal to an area function, right? It's a 1 to x integral ln t sine t plus 5 dt, and we're going from 1 to 7. Actually, let's write that down. So h of x is equal to integral from 1 to x, so function t sine t plus 5 dt, right? And what are we being asked to do? So we have a domain, 1 is less than or equal to x is less than or equal to 7, and then it says, where is h decreasing, right? So h is decreasing when its slope, which is h prime, is less than 0, right? So h prime of x, by the first fundamental theorem, right? So by f-talk 1, h prime of x is simply, this being an area function, h prime of x is just that, right? I put x in, and that's the rate of change of that area function. So h prime of x is simply ln of x sine x plus 5, right? So now I have to use my calculator to find out when this is greater than 0. So this is not really about Math 9. It's just about, graphing. You're going to go in your calculator, and you are going to just have to graph that function and figure out when it is greater than 0. So let's just review how we do that. Function editor, and then just put the function in here. And the function is ln, and then t or x sine x. Make sure you're in radian mode. Close that parentheses plus 5, right? So here I've got a nice function, and I can just go and see what happens when I graph it. I am seeing something, but you always want to now, adjust your window and all that good stuff. Let me double check that I'm in radian mode. Yep, I'm in radian mode. And then also, let me just make this window better. What you want to do is, whenever the question gives you a domain, make your window equal to the domain, right? So I'm going to put in 0 and 7 for my domain. I feel like that graph was really low, so I want to reduce my y max a good bit to maybe 5, and then I'm going to check it out, and that looks much better. And I can see this right here is my h prime function, right? This h prime function. I'm going to make this y min a little lower just so that I can check out what's happening there with that little dip. So there it's looking pretty good, and you want to play with your window so that you can clearly see your graph, okay? And now I basically need to find out these intervals. This is where h prime is positive, here and there, right? So we're going to find these 2 points. We're going to find those zeros, and you know how to do this. It's in the second calc menu under 0, so second calc 0. And then, or second trace, right? The calc menu is up here. Let me just position this a little better. I go second trace, right? Let me do that again. Second trace and then 0. And then it's going to ask you for a left bound. So go close to the 0, hit enter, and then go to the right of that, and then hit enter, and then hit enter again. And there's my first 0 at 4.3232. So I'm going to write that down. Okay, so the first 0 was 4 points. So these are my zeros. 4.3232. Okay, let's do the other one. So again, second trace, and then going to number 2, hitting enter, and then scoot over to the other one, right, for your left bound, and then scoot to the right bound, enter. There it is at 5.4613 is my second 0, right? So 0 number 2 is at 5. This video is a little bit hard to make with the calculator and the paper and all of this, but I'm almost there. 5.4613. Okay, so my answer is going to be B, because h is decreasing when h prime is negative. So h prime is negative in between those two x values, and so that is going to be the places where h is decreasing, or the interval where h is decreasing. So takeaway from this video is you want to be comfortable using Math 9, which is the integral, definite integral key on the calculator. And you want to be able to practice the net change theorem and use it in a variety of different ways. Net change theorem is the one that says f of b is going to be f of a plus the integral from a to b of f prime of x dx.